We're going to look at Affinity Photo's astrophotography stacking feature and how we can use it to stack narrowband deep sky data, specifically hydrogen alpha and oxygen, then create a bicolor composition. We will be using monochrome fit files for this example, and we will be doing the entire workflow in a 32-bit unbounded linear color space. No conversion to 16-bit is required to make use of Affinity Photo's adjustments, filters, and tools. To begin with, let's go to File and New Astrophotography Stack. This takes us into the dedicated persona or workspace for stacking. On the right-hand studio here, we have the Files panel, and this is where we can add our light frames and calibration frames. So let's start by adding the light frames. I will click Add Files down here, navigate to where my light frames are stored, and I'm going to stack the HA data first. But rather than having to go into this folder and select all of the files together, instead, I can just select the folder in which they are contained and then choose Open. Okay, so when you add the light frames, you can view tone-stretched versions of them just by clicking through the file list here. And you can also exclude or reject frames from the stack by disabling the eye icon. These two frames are okay though, so I will re-enable them. Let's move on and add our calibration frames. So I will add bias frames. Again, I can just select the top level folder and click Open. Then add the dark frames. Once again, just add the folder. And then the flat frames. Now, in this case, we can't just add the flats folder because this would be a recursive operation. If we go into the flats folder, you'll see I actually have two separate folders for the HA and the oxygen filters. So I just need to add the HA folder and click Open. Now, once we've added our light frames and various calibration frames, we could immediately try and stack them using this option on the context toolbar. However, you may notice just zooming in that we have some column defects. We can identify these for remapping using the Bad Pixel Map tool located on the Tools panel here. So if you haven't already tried to perform an initial stack, it will quickly analyze your dark and flat calibration frames for hot and cold pixels respectively. Now what we can do, particularly for hot pixels, is adjust the threshold up here. In fact, if I bring it all the way to the minimum value of 0.1, you will see it now identifies all of the noisy or inconsistent pixels, as well as the column defects. However, with this particular camera, especially to the right of the frame, there do remain some very faint column defects that are not identified even with the minimum threshold value. So we just need to manually add these into the Bad Pixel Map, and we can do so by changing the mode to column on the context toolbar here, then zooming in and just single-clicking over any column defects, no matter how faint. For example, this here looks to be a column defect, so we will identify it. Here is another one. Again, these are very faint. And the hope is that these would be rejected from the stack with enough light frames due to dithering. But nevertheless, it does help to try and identify them at this stage. Here is another faint one, and another one here. So I'm just quickly panning through my image, looking for any problematic areas. There's a very faint one, and another one here. Two more here. And I can see one there. Okay. Oh, just a few faint ones here. These look to be very faint columns. Okay, I think we've got the majority of them now. So when doing this process, sometimes it helps to just zoom back out and then just zoom in again, perhaps on a different part of the frame, just to double check. Now we have one singular hot pixel here that again has not been identified by modifying the threshold value. So we can switch back to the pixel mode, then just single click on that to add it to the bad pixel map. Okay, now once we've put in this manual work, we can save the bad pixel map as a preset by clicking on the cog icon up here, then choosing Create Preset. I'll name this after the telescope designation and click Create. This means that when we stack our oxygen data, we don't have to go through this time-consuming process again. We can simply just apply that bad pixel map as a preset. I will now stack the frames by clicking on the Stack option, and Affinity Photo will now calibrate, align, and stack all of our light frames together. Okay, once we have our stacked result, we can click Apply to move back to the photo persona. And on the Layers panel, here is our stacked image as a pixel layer. Above it on the Layers stack, we have a Levels adjustment, which is performing a gamma transform, and then a Curves adjustment, which is performing tone stretching. We will rename our pixel layer by clicking into the label and call it HA, so we know this is our hydrogen alpha data. We now have to repeat the process for the oxygen data. So I will go to File, New Astrophotography Stack, add my oxygen light frames, the bias frames, the dark frames, and finally, the oxygen filter flat frames. And as before, we will choose the bad pixel map tool, but this time, let's click the cog icon and apply that preset we created earlier. Then click Stack to stack the oxygen data. Okay, and as before, click Apply, and I will rename this pixel layer so I know that's my oxygen data. Now we have our two sets of data, we just need to get them into the same document. Let's use the HA document as a base, so I will go to my oxygen document, select the pixel layer, then copy using Command-C on Mac, Control-C on Windows, and paste it into my HA document above the HA pixel layer, so Command-V on Mac, Control-V on Windows. We can now shift-click and select the two layers, then change their blend mode to Add. Now, if we zoom in, you will notice that we have to align these layers. Not a problem. With them both selected, simply go to Arrange and Align Layers by Stars. Now we need to map each monochrome pixel layer to a specific color. To do this non-destructively, we can use a recolor adjustment layer. This recolors to red by default, so I will drag this into the HA pixel layer, then release the mouse button. Now we will duplicate this adjustment using Command-J on Mac, Control-J on Windows, and drag it into the oxygen layer and change the hue value to 240 degrees for blue. Okay, now we need to construct or synthesize our green color information from a mixture of these two layers. So it doesn't become too visually confusing, let's just collapse these two layers first. Then, first of all, we're going to duplicate the oxygen layer, so that's Command-J on Mac, Control-J on Windows. Then we're going to duplicate the HA layer, and we're just going to move this up one place in the layer stack. Now you could click drag, but if you like to be more precise with keyboard shortcuts, you can use Command and right square bracket on Mac or Control and right square bracket on Windows. Now I will shift click, select both of these layers, And to quickly set both layer opacity values to 50%, I can type 5 on the keyboard. Then I just need to expand both layers, double-click on the recolor adjustment, change the hue value to 120 degrees on both of them for a green color, and there we go. We now have our bicolor image constructed from two different datasets. Before we move on with retouching, let's crop our composition to exclude the areas where the two datasets do not overlap. So I can select the crop tool using C on the keyboard, and then just drag the crop handles in, then use return to commit the crop. Let's move up to the top of the layer stack and add another curves adjustment. That's Command M on Mac, Control M on Windows, and I'm going to use the picker option here by clicking on it. Then I'll just click drag over some of this faint nebula detail to sample from that region. I'm just going to push those tones up by dragging up on my mouse. Then I will click drag over an area of the background to sample from one of those tones, and this will help separate the background and the deep sky object detail. Now I may also want to just click drag and add another node here just to bring this slope down and avoid overexposing the brighter detail in the center here. To help create even more separation between the background and the detail here, we can use the merge visible operation to create a merged pixel layer of our work so far. I'll just name this merged. Then use the remove background filter from the filters menu. What this allows us to do is just click drag this sampler, position it over an area of the background, check sample color at handle, then just raise the output black level until we find a value that works for us, something like this perhaps, then click apply. Now let's do some color work. There are a plethora of adjustments you can use for this under layer and new adjustment layer, but for this example I will try HSL. So I'll just zoom into the nebula detail. Now on reds I will bring the saturation and the luminosity up. Across on yellows I will bring saturation up and luminosity up. Then cyans I will just bring saturation up, and for blues I will bring both saturation and luminosity up. In fact, I might just reduce the saturation slightly. Now this reveals some lovely color detail in the nebula, but we are unfortunately starting to bring out some noise. So to counteract this, we can select the merged pixel layer, and we can actually denoise non-destructively by going to Layer, New Live Filter Layer, Noise, and Denoise, and this will child layer into the merged pixel layer. So now we can just bring up the colors slider until that color noise disappears. The beauty of using a live filter is that you can revise your choices later on. For example, at this point, if I decided to try some luminance denoising as well, then close that filter dialog down and zoom out to 100%, I might decide that actually it sacrifices too much of the texture and detail. So I can simply double-click that noise reduction filter layer and then reduce the luminance slider to bring back some of that texture. Okay, back at the top of the layer stack, to complete our color work, let's use a selective color adjustment. On reds, I'll bring the cyan all the way down. Then on yellows, I'll bring the cyan down and perhaps increase the yellow. And that gives us this lovely fiery gold tone. Finally, across on neutrals, I might just bring cyan to the left for a slight red bias. And then I might add a final brightness and contrast adjustment to complete the retouching work. Okay, then I might just select the crop tool again using C on the keyboard and just crop in for a tighter composition. And there we go. I will leave my editing there, but I would encourage you to experiment further with your own astrophotography workflow. Do have a look at the other astrophotography video tutorials, as I use various different techniques and features in each one, depending on the image being edited. I hope you found this video useful, and thank you for watching.